Hello and welcome to my channel. In this video we are going to solve examples from Quadratic chapter from International Advanced Level Pure Mathematics 1 having the subject code WMA1101 from May-October 2020 question paper till June 2021 question paper. So let us start with the first question. F of x is given as 3 plus 12x minus 2x square. Express f of x in the form a minus b x plus c the whole square, where a, b and c are integers to be found. Now the given format is the format of completing the square method. So we have to solve the f of x given such that we have to get it in this form. So let us start with the first one, the part A. So the question given is f of x is equal to. Let me just rearrange this given expression by taking the highest power of x first. So it is minus 2x square plus 12x plus 3. So this is what is given. Now I'm going to separate out the first two terms. So I'll write it as minus 2x square plus 12x, and I will take negative 2 common from these two terms. That is, I'm going to factorize it. So I'll take negative 2 outside and it becomes x square minus 6x. Now let me take this whatever I have got over the next step, and I'm going to solve the brackets by using the completing the square method. So let me keep minus 2 outside the bracket, and for completing the square method I'll keep the x square as it is. I'll keep the negative 6x the same way. Now for completing the square method we have to divide the x term by 2. So whatever coefficient we have with x, we divide it by 2. So we get it as 3. That is what we are going to add and subtract the square of the number. Just now what we got by dividing by 2. So we get it as 3. So we add 3 square and we subtract 3 square. Now after getting this, we are going to write negative 2. Now we look at the first 3 terms of this, and I take only the first term from the first 3 terms without the square. Then I take the negative sign from the middle term, and I take the last term of the expression I have considered without the square, and I'm going to whole square it. So if you want to go through the steps of completing the square method, I will attach the link of the video I have uploaded on completing square method, so you can go through it and you will be able to understand the steps I am doing over here. And here it becomes minus 3 square is 9. So this is what we get. Now let me just open up the brackets. So it becomes minus 2 x minus 3 the whole squared, and minus 2 times minus 9 gives us plus 18. So this is what is for the first 2 terms which we have taken in this expression. Now let me substitute whatever I got here in this expression of f of x. So we get it as f of x is equal to, so in the first 2 terms which I had considered, I got the answer as minus 2 times x minus 3 the whole square plus 18. So I'm going to substitute that. So x minus 3 the whole square plus 18, and then the last term which is plus 3. So I write plus 3. Further simplifying it, we get it as minus 2 x minus 3 the whole squared plus 21. Now they want us to get the answer in this format, a minus b x plus c the whole squared. So I'm going to rearrange it and write it as 21 minus 2 x minus 3 the whole squared. So let us see it matches with the format they have given here or not. So here it is a minus b x plus c the whole squared. This is what was given here. So by comparison we can say that in place of a we have 21, in place of b we have 2, and in place of c we have minus 3. So these are the integers we have got for a, b and c. This is how we solve the part A of this question. Now let us look at the part B of this question. The curve with equation y equal to f of x minus 7 crosses the x-axis at the points P and Q and crosses the y-axis at the point R. So let me just draw over here so that you'll get an idea. So okay, this is the y-axis and this is the x-axis and this is the origin. So the curve looks somewhat this way. Now it is an inverted U because here in the given expression f of x, x square is a negative term. So whenever x square is a negative, that time the curve goes upside down. Now they have said that the curve meets the x-axis at points P and Q. So let me take this as point P and this as point Q, and crosses the y-axis at point R. So it will be somewhere around here. Find the area of the triangle PQR. So they want us to form a triangle out of this given coordinates. So this is what we need to find. We have to find out the area of this triangle. Now to find out, they have given us the equation of the curve, which is y is equal to f of x minus 7. Now f of x was given in the previous question A as 3 plus 12x minus 2x square. Now I'm going to put minus 7 over here. This thing comes over here. So solving it, we get it as y is equal to, rearranging it, minus 2x square plus 12x and plus 3 and minus 7 becomes minus 4. The hint they have given is the curve with this expression crosses the x-axis at points P and Q. That means when the curve is crossing the x-axis, the y becomes 0. So we put y equal to 0 is equal to minus 2x square plus 12x minus 4. So if we solve this expression, we will be getting the coordinates of P and Q. Let us use the quadratic formula to solve this, which is given as x equal to minus b plus minus square root of b square minus 4ac over 2a. We know that here a is the coefficient of x square, so it is negative 2 here. B is the coefficient of x, so it is 12 here. And c is the constant term from this expression, so we get it as negative 4. So substituting a, b and c in the above formula, we get it as x is equal to minus 12 plus minus square root of 12 square minus 4 times a is minus 2 and c is minus 4 over 2 times minus 2. So it becomes minus 12 plus minus, let us check what we get the square root term here. So we have it as square root of 12 square minus 4 in the bracket minus 2 times minus 4. So we get it as 4 root 7. So let us write here 4 root 7 over minus 4. We can further factorize this and take the 4 common out, or negative 4 also we can take it out. So in this case I'll be taking negative 4 common, because in the denominator I have negative 4, so it becomes easy to divide the numerator and denominator. So here we are left with 3 plus or minus square root of 7 over minus 4. So you can see we can cancel off the minus 4 and minus 4, and we are left with 3 plus or minus square root of 7. Now these are the two values of x which we got, and one of the coordinates are for p and one of the coordinate is for q. So we can write the coordinate of p as 3 plus square root of 7, comma, since p is on the x-axis, the y coordinate will be 0, so we'll write it as 0, and q we can take it as another coordinate of x, which is 3 minus square root of 7, and since q is also on the x-axis, we will keep the y coordinate as 0. So these are the two coordinates of the x-axis. Now the next thing they have given in the question is the curve crosses the y-axis at the point R. So you can see the curve is crossing the y-axis at point R. So on the y-axis the x coordinate is going to be 0. So in this expression which we got by solving the given above equation, in this case the x coordinates becomes 0. So we are going to substitute x value as 0 over here. So we get y is equal to, if x becomes 0, this term becomes 0, this goes down to 0, and we are left with negative 4. So y is negative 4. So we get the coordinates of r as 0, comma, negative 4. So we got the coordinates of p, q and r. Next we have to start getting the area of the triangle. So area of the triangle, we have the formula as, so area of triangle PQR is given as half times base. Base is, we can take base as PQ here. So half times base is PQ times height. Height is nothing but the perpendicular height over here for this triangle. This is the perpendicular height. So we can take it as from the origin to the point R. Next, we need to know what is the distance between the points P and Q. So we are going to use the distance formula over here. So distance formula, we are going to write it as, distance formula is given as square root of x1 minus x2 the whole square plus y1 minus y2 the whole square. This is the distance formula, and we need to find out the distance between the 2 points P and Q. So here I can take it as x1 comma y1 for P, and for Q I can take it as x2 comma y2, and for P we had got the coordinates as 3 plus root 7 comma 0. So it is 3 plus root 7 comma 0, and for Q it is going to be 3 minus root 7 comma 0. So let us substitute these values in the formula which we have written. So here we get it as square root of x1 is 3 plus root 7 and x2 is minus 3 minus root 7. The whole thing is squared, and the y terms or y coordinates for P and Q were 0. So 0 comma 0. So here it becomes 0 minus 0 the whole squared. So let us solve this further. This is square root of 3 plus root 7. Let me open up the brackets. It becomes minus 3, and minus of minus is plus root 7. the whole squared. So you can see that plus 3 and minus 3 gets cancelled, and we are left with square root of root 7 plus root 7 is 2 root 7, the whole squared. Now the square root gets cancelled with the square term, and we are left with 2 root 7. So this is the distance between P and Q. Now once we get the value of P and Q, we are coming over here and substituting the area of triangle PQR. So area of triangle PQR is equal to half times, in place of PQ we will write 2 root 7, and in place of OR, that was the perpendicular distance, here we can see we have the perpendicular distance as 0, -4. This was what we got for R, the coordinate. So the Y value we are going to take it as 4. So when we are calculating the area, do not consider the signs. So we are going to just take it as positive 4, and 2 and 2 cancels, we are left with 4 root 7. This is what we get the area. Now the question asked us was in the form of m root n, where m and n are integers to be found. So comparing it with the answers we got, this is m root n. So by comparison we can say that m is equal to 4 and n is equal to 7. This is how we solve the part B of the question. Now let us look at the next question from January 2021 question paper. In this question you must show all stages of your working, and solutions relying on calculator technology are not acceptable. F of x is given as 2x minus 3 root x minus 5, where x is greater than 0. Solve the equation f of x equal to 9. So let us start solving the part A. Part A, they have given f of x is equal to 2x minus 3 root x minus 5, and f of x is given as 9. So in place of f of x, I am going to substitute 9. So 9 is equal to 2x minus 3 root x minus 5. Now here I am going to make a small rearrangement. That is, I am going to take the minus 3 root x on the other side of the equation, and I am going to take 9 on the right hand side of the equation. So it rearranges as 3 root x is equal to 2x minus 5 minus 9. Now I am going to simplify this equation further as 3 root x is equal to 2x minus 14. Now to get rid of the square root, we can square on both the sides, and the equation becomes 9x is equal to, I can expand this and write it as 2x minus 14 times 2x minus 14. Now expanding the brackets, we get 2x times 2x is 4x square, and 2x times minus 14 gives us minus 28x, and again minus 14 times 2x is minus 28x, and minus 14 times minus 14 gives you plus 196. Now further simplifying the equations, we get 4x square, and minus 28 gives us minus 56x. Now let me take the 9x on the other side, so it becomes minus 9x plus 196 is equal to 0. So one last step for simplifying this, 4x square. Now these two are like terms, so minus 56 and minus 9 gives you minus 65x plus 196 is equal to 0. Now to solve this algebraic expression which we got, we can use the quadratic formula, which is x equals minus b plus minus square root of b square minus 4ac over 2a. So a is the coefficient of x square, so a is 4. B is the coefficient of x, so we get it as negative 65. And c is a constant term, so here in this case it is 196. So substituting the values of a, b and c in the above expression, we get it as, so x is equal to minus of minus 65 plus minus square root of b square is minus 65 square minus 4 times a is 4 and c is 196 over 2 times 4. So let us see what we get. Here it is minus of minus is plus, so plus 65 plus minus, let us see what we get under the square root. It is square root of minus 65 square minus 4 times 4 times 196. So we get it as 33. So it reduces as 33 over 2 times 4 is 8. So we have two values of x now, x equal to 65 plus 33 over 8, and another x value is 65 minus 33 over 8. So let us check how much we get here. So it is 65 plus 33 divided by 8, so it is 49 over 4 or 12.25. So 12.25 is the first value of x, and another value of x is 65 minus 33, we get it as 32 divided by 8, we get it as 4. So these are the two values of x. Now once we get the values of x equal to 12.25 and x equal to 4, there is one last thing which we need to do, that is pick one of the correct answers out of the two. So here we are going to substitute 12.25 in the above f of x equation and check whether we get it as 9 or not. So if it gives me f of x equal to 9 after substituting x equal to 12.25, then the value of x is correct. So let us check first for the 12.25. So here the f of x is given as 2x minus 3 root x minus 5. So let us substitute first 12.25 and see. So 2 times 12.25 minus 3 root 12.25 minus 5. It's not necessary to show these steps in the exam. You can do it directly on the calculator and cross verify. Here I am just showing you how to check on the calculator. So 2 times 12.25 minus 3 root of 12.25 and minus 5. So that gives us f of x is equal to 9. So this value of x is acceptable. Now let us check for x equal to 4 whether we get f of x equal to 9 or not. So let us do it directly on the calculator. So we have 2 times 4 minus 3 root 4 and then we have minus 5, which gives us negative 3. So we do not have f of x equal to 9, but we get f of x equal to negative 3. Hence x equal to 4 cannot be taken as a solution. So we have just one solution of x here, that is x equal to 12.25. or it can also be kept as 49 over 4. So this is how we solve and get the final value of x for the part A of the question. Now let us look at part B of the question. Solve the equation f double dash of x is equal to 6. Now this question belongs to the chapter 8, which is differentiation. So you can see that they have combined the quadratics chapter with differentiation. Now double dash, in the sense they want us to differentiate the f of x expression 2 times. We can also call it as second derivative also. So first of all, let us write down what f of x is given here. So f of x is 2x minus, so f of x is equal to 2x minus 3 root x and then minus 5. So this is what f of x is given. Now let us differentiate it for the first time. So it is given as first derivative f dash of x is equal to, now when we are differentiating it, we write it as 2. Now we take the power of x, which is 1 here. So 2 multiplies with 1 multiplies with x to the power of x reduces by 1. So this is what is called as differentiation of the x term. Now square root of x is nothing but, we can write it as x to the power of half. So let me write it this way because it becomes easy to differentiate it. Now I write it 3, which is already over here, multiplies with, the power comes down, 1 over 2. Then again x is reduced by a power of 1. And one more thing, the differentiation of a constant term is always going to be a 0. So we can put a 0 here, or we can just skip writing this term. Now let us simplify this differentiation. We get it as 2. Now x to the power of 1 minus 1, which is 0. So x to the power of 0 is 1. So this entire term becomes only 2. Minus, this becomes 3 times 1 over 2 is 3 over 2. And x to the power of 1 over 2 minus 1 is minus 1 over 2. Now this is the first differentiation which we did. But in the question they have told us to find the second derivative of the given f of x. So let us differentiate the first derivative of f of x again. So we get it as f double dash of x is equal to, now as mentioned before, the differentiation of a constant term is 0. So the differentiation of 2 becomes 0 minus 3 over 2. Now again we have to differentiate x to the power of minus half. So this minus half power comes down. So minus half, and again x is reduced by a power of 1. This is how we differentiate it. Now simplifying the answer, we get minus of minus is plus. So 3 over 2 times 1 over 2 gives us 3 over 4. And x is raised to a power of minus 3 over 2. Addition of these two powers. Now once we have got the second derivative of f of x, in the question it is mentioned that solve the equation when f double dash of x is equal to 6. So here in place of f double dash of x, or second derivative of f of x, we write here as 6 is equal to 3 over 4 x to the power of minus 3 over 2. Now a little bit of rearrangement. This 3 over 2 will be moved on the other side of equal to sign. So it reciprocates and becomes 4 over 3 equal to x to the power of negative 3 over 2. So here we get 3 one times and 3 two times. There is a division. So we get 8. 2 times 4 is 8 is equal to x to the power of negative 3 over 2. The next thing we are going to do is we are going to transfer the power, that is -3/2, on the other side of equal to sign, and the power flips. So here it becomes 8 to the power of negative. The negative remains, but the power reciprocates and becomes 2/3. Now 8 can be written as 2 to the power of 3. So here in place of 8 we replace it by 2 to the power of 3, which multiplies with the power -2/3. Again there is a division, 3 one times, 3 one times, and we are left with x is equal to 2 to the power of -2. We can change this negative power into a positive power by reciprocating this 2/1 as x is equal to 1/2, and hence the power becomes positive. So in turn the square of 1/2 is 1/4. So this is the answer for the part B of the question, which is x is equal to 1/4. Now let us look at the next question, which is also from January 2021 question paper. Figure 4 shows a sketch of part of the curve C with equation y equal to f of x, where f of x is given as 3x minus 2 the whole squared times x minus 4. So they have given a curve here, curve C, and its equation is given by this f of x. Deduce the values of x for which f of x is greater than 0. So f of x, whenever they give, this means it has to be y should be greater than 0, because f of x is nothing but the y-axis. So we have to come back to the graph and look at the graph carefully and check where is my curve going above the 0. As you can see here, this is the original x-axis, this is the y-axis, and this entire portion of the curve is below the x-axis. That means my y is less than 0 at this portion of the curve, and it goes above 0 for this portion of the curve, that is only from this point upwards. After analyzing this, you can see that the curve touches the x-axis at 2 points. This is one point and this is another point. So we have to find out what are the 2 points at which the curve is touching the x-axis. For that we have to look into this given function. So here, if the curve is touching the x-axis, then the y has to go down to 0. So what I'm going to do here is, for the part A, it's given as f of x is equal to 3x minus 2 the whole squared times x minus 4. This is what is f of x given. So if the curve is touching the x-axis, the y coordinate is going to be 0 here. So the y coordinate of the curve, let me take it as 0. So this is equal to 3x minus 2 the whole squared times x minus 4. So we have two factors here, that is x minus 4 is equal to 0, and we have another factor here, 3x minus 2 the whole squared equal to 0. So one value of x we have it as 4 here, and another value of x we get here is, since the square goes on the other side, it becomes square root of 0, which is again 0. So we have 3x minus 2 equal to 0, and we get x is equal to 2/3. So these are the 2 points where the curve is touching the x-axis. So obviously 2/3 should be over here, and this is the point 4 for the x-axis. And as we saw, from this point onwards till this point, the y is less than 0 because it is below the x-axis. That means when x becomes greater than 4, the curve starts to go in the positive direction. It is not equal to 4 also, because when x becomes equal to 4, the curve becomes 0 at this point. That's why x has to be greater than 4 for the y-axis to be greater than 0. Hence, we write here simply the value of x has to be greater than 4. This is the answer for part A of the question. Now let us look at the part B. Expand f of x to form ax cube plus bx square plus cx plus d, where a, b, c and d are integers to be found. So this is for 3 marks, so we have to elaborate the steps. We have to just expand these 3 brackets and multiply and expand them. So let us start with the part B. So f of x is given as 3x minus 2 the whole square multiplied it with x minus 4. So I'm just going to expand the first 2 brackets because it is a square. So it becomes 3x minus 2 and 3x minus 2, and I'll keep the third bracket the same way. Now let me multiply the first 2 brackets and expand them. So 3x times 3x becomes 9x square, and 3x times minus 2 gives us minus 6x, and minus 2 times 3x gives us again minus 6x, and minus 2 times minus 2 gives us plus 4. So this is the expansion of first 2 brackets. Again x minus 4 remains untouched. Here I can further simplify this and write it as 9x square, and minus 6x and minus 6x are like terms, so I will combine them and write it as minus 12x plus 4 and then x minus 4. Now I am going to expand this bracket along with this bracket. So 9x square with x gives us 9x cube. 9x square with minus 4 gives us minus 36x square. Minus 12x times x gives us minus 12x square. Minus 12x times minus 4 gives us plus 48x. And plus 4 times x gives us plus 4x. And plus 4 times minus 4 gives us minus 16. So we can simplify this, and combining the like terms we should be getting it as 9x cube, and this is 36x square and minus 12x square, so both the signs are same, so we can combine it and write it as 48x square, and plus 48x plus 4x, again like terms, so we can write it as plus 52x minus 16. This is our f of x in the most simplified manner. So let us check what format they want us to get the answer in. That is ax cube plus bx square plus cx plus d. So let us first write it down. It has to be of the form ax cube plus bx square plus cx plus d. So by comparing the coefficients of x term, we get a as 9 and value of b is negative 48 and value of c is 52 and value of d is negative 16. So these are the values of a, b, c and d we get for part B. Now let us look at the part C of this question. The line L, also shown in figure 4, passes to the y-intercept of C and is parallel to the x-axis. So this is the line they are talking about, which is passing through the y-intercept of the curve over here, and it cuts the curve at 2 points P and Q, as we can see, and it is also parallel to the x-axis. The line L cuts C again at points P and Q. Using algebra and showing your work, find the length of line PQ and write your answer in the form k root 3, where k is a constant to be found. So here, these are the hints they have given us to solve the given example. So they said that first of all, the line L is parallel to the x-axis. So the equation will be y equal to something, since it is parallel to the x-axis. The next hint they have given is it cuts the y-intercept of the curve as well. So the y-intercept, if we want to find for the curve, the x coordinate is going to be 0 for the y coordinate. So what we are going to do is, again we'll be taking this f of x expression for the curve. Let me write it down again. So here they have given f of x is equal to 3x minus 2 the whole square times x minus 4. So for the y-intercept, because it is on the y-axis, so the y-intercept, we have x is equal to 0. So we substitute x equal to 0 in the above expression to get the y-intercept, and hence we get it as f of x or f of 0 is equal to 3 times 0 minus 2 the whole square times 0 minus 4. So we have it as the y coordinate or y-intercept of that point, we have it as negative 2 square and negative 4. So this is 4 times minus 4, which gives us y coordinate as negative 16. And this is also the equation of the line above. This is y equal to minus 16, since it is parallel to the x-axis. Now the next hint they gave is it cuts the curve at the points P and Q. So whenever you hear the words or see the words cuts the curve or intersects or meets the curve, that means the equation of the line has become equation of the curve. So at this point we can say that equation of line has become equal to equation of the curve. Equation of curve. It is at point P and Q. At P and Q. So equation of the line, we got it as y is equal to negative 16. So we'll write it as negative 16 here. Equal to equation of the curve, we have it as 3x minus 2 the whole square times x minus 4. So here we had already expanded this bracket in part B. So let us make use of it. So we had 9x cube minus 48x square. So 9x cube minus 48x square. And here it was 52x minus 16. So plus 52x minus 16 is equal to minus 16. So let us solve this equation. Minus 16 on this side and minus 16 on the other side gets cancelled. So we are left with 9x cube minus 48x square plus 52x is equal to 0. Now we can factorize this by taking the x term common from this. So it remains as 9x square minus 48x plus 52 equal to 0. So we have to factorize these now. So one factor is x equal to 0 and another factor is 9x square minus 48x plus 52 is equal to 0. So I'm going to use here the quadratic formula, which is given as x equal to minus b plus minus square root of b square minus 4ac over 2a. So here we have a as the coefficient of x square, which is 9. We have b as coefficient of x, which is minus 48. And we have c, which is a constant, 52. So let us substitute all these values in this above expression. So we have x equal to minus of minus 48 plus minus square root of minus 48 square and minus 4 times A is 9 and C is 52 over 2 times 9. So we have minus of minuses plus 48. Let us see what we get the square root term. So here we have square root of minus 48 square and minus 4 times 9 times 52. So we get it as 12 root 3 over 18. Common out from the numerator, so 3, and here remains 16 plus minus 4 root 3 over 18. So here the 3 cancels with 18, 3 1 times, 3 6 times. So we are left with 16 plus minus 4 root 3 over 6. So we have now 3 values of x, that is x is equal to 0, and we have x is equal to 16 plus 4 root 3 over 6, and another value of x is 16 minus 4 root 3 over 6. Now x equal to 0, which we got, is at the y-intercept, and at P we can write it as 16 plus or 16 minus 4 root 3 over 6, and for the Q we can write it as 16 plus 4 root 3 over 6. So these are the 3 coordinates of the given curve. Now here in part C they want us to find the distance or length of line PQ. So length of line PQ is this part, that is between Q and P. So the length of PQ, is given as Q minus P, and Q we had taken as 16 plus 4 root 3 over 6, and P is given as 16 minus 4 root 3 over 6. Here we can see the denominators are same, so we will make a common denominator as 6 and write the numerator as 16 plus 4 root 3 and minus 16, and minus of minuses plus 4 root 3. So we can see plus 16 and minus 16 gets cancelled, and 4 root 3 plus 4 root 3 gives us 8 root 3 over 6, which can be simplified as 2 4 times and 2 3 times. So we have 4 root 3 over 3, which is the distance between the points P and Q. So this is how we solve the part C of the question. Now let us look at the next question from June 2021 question paper. There is a function given as f of x equal to ax cube plus 6a plus 8x square minus a square x, where a is a positive constant. Given f of minus 1 is equal to 32, show that the only possible value for a is 3. So they have given us a hint over here, that is f of minus 1 is 32. That means in place of x we are going to substitute -1 in all the places. So let us start with the first one, that is a1. So it's given that f of minus 1 is 32, and they have given us f of x. So here it is going to be f of minus 1. So I'm going to substitute -1 in all the places of x. So a -1 cube plus 6a plus 8, so 6a plus 8 x squared, so it is going to be -1 squared, and finally we have minus a square x. So minus a square times minus 1. So f of negative 1 they have given us 32. So here in place of f of negative 1 I'll write 32 is equal to, this becomes minus a and this is plus 6a plus 8 and minus of minus becomes plus a square. So let us rearrange this and we can get it as a square and minus a plus 6a are like terms, so it becomes plus 5a, and if we take 32 on this side it becomes negative 32 plus 8 is equal to 0. So further solving this we get a square plus 5a and this becomes minus 24 equal to 0. Now we have to factorize this, so I'm going to use splitting the middle term. So for that we have to multiply the first coefficient with a square with the last constant 24. So we get 1 times negative 24 is a negative 24. And now we have to start finding the factors of negative 24, which when added or subtracted should give me plus 5. So the combinations can be for negative 24, it can be 8 and negative 3, because 8 times negative 3 gives us negative 24 and 8 plus negative 3 gives us positive 5. So I'm going to split this positive 5 a as a square plus, so I'm going to split it as 8a minus 3a minus 24 equal to 0. So let me factorize this. The first two terms I'm going to combine it and take out the common term, which is a, so remains is a plus 8, and in these two I can take out negative 3 common out, so in the bracket remains a plus 8 equal to 0. So we have it as a negative 3 as one factor and a plus 8 as another factor. So equating each one equal to 0, we get it as a minus 3 equal to 0 and a plus 8 equal to 0. And here a will be equal to 3 and here a will be equal to negative 8. So we have to discard the negative 8 and take only a equal to 3 as our answer, because in the question they have clearly mentioned that a is a positive constant and show that the only possible value for a is 3. So we have shown that a is equal to 3 and a is not equal to negative 8, because a is positive here and a is negative here. Now let us look at the part 2 of this question. Using a equal to 3, solve the equation f of x equal to 0. So they want us to substitute 0 in place of f of x, and in place of a we have to substitute 3 and solve the given expression. So let us start substituting the value of a as 3. So I have written already the f of x. So they told us that f of x is 0, so let me put a 0 here, and in place of a we have to put 3, so it becomes 3x cube plus 6 3 times is 18 and 18 plus 8 is 26 x square, and minus 3 square becomes 9x. Now let us factorize this equation by taking x common out. So we get x in the bracket 3x square plus 26x minus 9 equal to 0. So now we get two factors here, that is, one is x equal to 0 and another factor is x square, 3x square plus 26x minus 9 equal to 0. I'm going to solve this quadratic expression using the quadratic formula, which is given as x equal to minus b plus minus square root of b square minus 4ac over 2a. So here a is nothing but the coefficient of x square, so it is 3 here, and b is the coefficient of x, which is 26, and c is the constant term, which is minus 9. So let us substitute these values over here and see what we get. So x is equal to negative 26 plus minus square root of b square is 26 square minus 4 times a is 3 times negative 9 over 2 times 3. So here we get negative 26 plus minus square root of this entire term gives us 28 over 2 times 3 is 6. So we have two values of x here. So one is negative 26 plus 28 over 6, and another value of x is negative 26 negative 28 over 6. So here we get it as 2 over 6, which is nothing but 1 over 3, and another one is x is equal to negative 54 over 6, which is x equal to negative 9. So we have got three values of x here. So first value of x is x equal to 0, and next value is 1 over 3, and the last value is negative 9. So this is how we solve the second part of this question. Now let us look at the part B. Now the question says, hence find all real solutions of 3y plus 26y to the power of 2 over 3 minus 9y to the power of 1 over 3 equal to 0. Now to solve these kind of examples, we already had f of x given as ax cube plus 6a plus 8 x square and minus a square x in the part A of this question. And by substituting a equal to 3 in this function and equating f of x equal to 0, we had got the equation as, we had got it as 3x cube plus 26x square minus 9x equal to 0. So let us consider this equation which we had got in part A to solve this part B. So we have here 0 equal to 3x cube plus 26x square and minus 9x. There is a relationship between this first equation and this equation which we had got in part A question. So just let me rewrite this equation just below this equation as 3y plus 26 y to the power of 2 over 3 minus 9y to the power of 1 over 3 equal to 0. Now to solve this equation, one way we can do over here is we have to check the smallest power of x, that is this, and equate it with the same coefficient in the y term. So here if it is minus 9x to the power of 1, I'm going to equate it with the term having the same coefficient as negative 9 in the y expression. So looking at it, we can see that these two are having the same coefficient, negative 9 and negative 9. So let me just equate it and write it as negative 9x or negative 9y to the power of 1 over 3 is equal to negative 9x. Since the coefficients are same, I can cancel the negative 9 and negative 9 from both sides, and you are left with y to the power of 1 over 3 is equal to x. Now let me transfer the fractional power on the other side of equal to sign, so it becomes y equal to x to the power of 3 over 1. This is by laws of indices. The power flips or reciprocates when you are sending it on other side of equal to sign. So I can simply write it as y is equal to x cube. So this is the expression of y in terms of x. Once we get this expression, in part A, we had already got three values of x, that is x equal to 0, 1 over 3 and minus 9. So we have to come over here and substitute one by one in the values of x to get respective values of y. So when x is equal to 0, we have y is equal to 0 cube, which is 0. And when x is equal to 1 over 3, we get y is equal to 1 over 3 cube. So this becomes 1 over 27. And finally we have x equal to negative 9. So we have to substitute negative 9 in place of x. So we get it as negative 729. Now once we get the values of y as 0, 1 over 27 and minus 729, we have to make sure that we substitute the values of y in this expression and check whether we get it as equal to 0 or not. So let us start with the first one, that is 3y plus 26 y to the power of 2 over 3 minus 9 y to the power of 1 over 3 equal to. So let us check for the first one, that is when y is equal to 0. So when y is 0, the first term which we got, we are just going to multiply all the terms with 0. So 3 times 0 plus 26 times 0 to the power of 2 over 3 minus 9 times 0 to the power of 1 over 3. So this gives us equal to 0. Hence this is a solution. Now we have to also check for y equal to 1 over 27. You can obviously make use of the calculator over here. Now you do not have to show all the steps where we are substituting the values of y one by one. You can directly check it out in your calculator, and whichever satisfies the equation and whichever makes your f of x equal to 0 over here, that needs to be selected as your answer. So for the next one where we got 1 over 27, let me just substitute and show it to you. So here we can write it as 3 times, so 3 multiplied with 1 over 27. In place of y it is 1 over 27, and then plus 26 multiplied with 1 over 27, but it is raised to a power of 2 divided by 3, and then we have minus 9, and again we have it as 1 over 27, and this is raised to again a power of 1 divided by 3. So let us execute and check. Here we get the answer as 0. So that means this y equal to 1 over 27 is also a value of the y which satisfies the equation. Now finally we have to check for negative 729. So let us see what we get over here. So we have here as 3 multiplied with negative 729, and then plus 26 multiplied with negative 729 raised to the power of 2 divided by 3, and then we have negative 9 multiplied with negative 729, then again raised to a power of 1 divided by 3. So here also we get it as 0. That means this is also a solution of the given equation. So all the three values are correct. So this is how we solve the given expression, that is for part 1. Now for the part 2 we do the same thing, So let me write down the f of x, and here again we are going to compare it and write it as, so this is given as 0 is equal to 3 times 9 to the power of 3z plus 26 and 9 to the power of 2z and minus 9 to the power of z. So now we have to compare this expression with this expression. So here also similarly I am going to look at the same coefficients, that is -9 and -9, and I am going to compare this term with the last term. So by comparison we can write it as, so this is for the second one, so it was -9x is equal to -9 to the power of z. So again the coefficients are same, so -9 and -9 cancels, and we have 9 to the power of z is equal to x. Now once we get the expression of z in terms of x, now again we had three values of x as x equal to 0 and 1/3 and -9. So let me substitute the value of x as x equal to 0 in the first one. So we get it as 9z is equal to 0. This means 9 to the power of something should give us equal to 0, which is not possible, because if you substitute the values of z as 0 we get it as 1, and if we substitute 9 as 1 we get it as 9, and if we keep on increasing the values of z you can see that we will not get 0. The answers will be in higher order or higher magnitude. And if we take negative values of z like -1 we get it as 1/9, and if we keep on decreasing it also, -3 we get it as 1/729, but it will not be equal to 0. So for this particular term we have no solution, that is we have no solution for z. So we just simply write it as no solution. Now let us look at the next one, that is when x is equal to 1/3. So here we have 9z is equal to 1/3. So 9 I can write it in terms of 3, that is 3 square raised to the power of z is equal to 3 to the power of -1. That is by using the laws of indices I can just flip this 1/3 as 3/1, but the power becomes negative. Here it was positive, so when I pull it up it becomes -1. So we have simply here as 3 to the power of 2z is equal to 3 to the power of -1. Once we have the same bases we can simply cancel off the bases and write the powers as 2z equal to -1. That is, we are equating the powers. Or we can simply write it as z is equal to -1/2. So this is the first value of z we got, and here it was no solution, but when x equal to 1/3 we get z as -1/2. Now let us look at the next value of x, which was x equal to -9. So in this case we have 9 to the power of z is equal to -9. Now in this case as well we have to check what will be the power of z that gives us -9. So we see that there is no power of z which gives us equal to -9. So you can check it out by giving different values of z. For example, z you can take it as -2 or 0 and take some random positive values and put it in this equation and check. So 9 to the power of -2 gives us 1/81, which is not equal to -9, and 9 to the power of 0 we get it as 1, which is again not equal to -9, and 9 to the power of 4 Let me check that. It is definitely not going to be negative 9, but let us just check. So 9 to the power of 4. So we get it as 6561, so which is also not equal to negative 9. So again we see that there is no solution for z whenever x is negative 9. So we write here again as no solution. So here we have the value of z as only the one value which we got, which is a negative 1/2.